Okay, so last lesson we talked about arithmetic sequences and series. Now we're going to talk about geometric. And I know normally when we see this word geometric, we're thinking of geometry. Well, in this scenario, what I really want you to think about is exponential. Okay, so a geometric sequence is an exponential pattern. Do you remember what type of pattern the arithmetic sequence was? Anybody? It was a linear pattern, whereas geometric sequence is a exponential pattern. Which grows faster? Linear, exponential?
Exponential.
Exponential. So these sequences are going to deal with some pretty big numbers. Where each term is found by multiplying, you could also think dividing, by a common number. Okay, what did we do for arithmetic sequences? We added a number or subtracted a number. Now we're going to be multiplying by a number. And that's the difference between these two sequences. So sometimes you can kind of just look at the numbers and do this in your head. So like from 3 to 9 to 27 to 81, what's the pattern? You're multiplying by 3, okay? So times 3 times 3 times 3. So instead of D for common difference, which is what we did before, we use R for common ratio. Okay, so R is 3. All right, so that's what the common ratio, that's that common number. All right, now if you're not good with number sense, or if you're having a hard time on another problem, you just got to go back and go divide. 9 divided by 3, 27 divided by 9, 81 divided by 27. Those should all be the same number. Okay, so what do you think we're multiplying by on B? Yeah, negative 1/3. Okay, so if some of you were thinking, hey, I thought we were dividing on B. I thought we were dividing by 3. Well, you are, but the common ratio has to be multiplication. So we're multiplying by negative 1/3. And so I'm going to take this opportunity to show you how you could, on a problem, find this common ratio. Just go 1 divided by negative 3. Put that negative in. Okay, and hit math fraction. Okay. And then you could do the next thing. And so I'm going to skip to the last one. So if I wanted to do 1/9 divided by negative 1/3, it should give me that same common ratio. Now you may get a decimal. You can just hit math fraction. And every time you divide the next term by the previous term, you should get that same common ratio. That's going to be important on problems where it's not as obvious. Okay, so if what we're doing each time is we're multiplying, okay, by 3, then my nth term should be something times R so many times. Okay, so let's think about it this way. On this one, I start with 2. I'm timesing by 3, and so I'm going to put it in parentheses to a certain power. So let's see if this works. Let's see if this works. So see how this is the first term? This is the second term. This is the third term. We should be able to plug in 1, 2, and 3 and get these numbers, 2, 6, and 18. So if I plug in 1 in for n, I'm going to have 2 times 3 to the 1 power. Will that give me a 2? No, what will it give me? A 6. Okay, now let's plug in 2 in for n. What's 2 times 3 squared? So 3 squared is 9, times 2 is 18. So I'm 1 off. So I either need to go plus 1 or minus 1 here. Which one do you think? Minus 1. That's the formula, actually. The first term times R to the n minus 1. And you don't simplify this. And you don't have to memorize this. So if we're looking at something like A, it says find the formula for the nth term, okay, and then use it to find the term specified. So the first thing we have to do is find A sub n. Well, they give us the first term is 4, and they give us R is 2. So this one's like they're just handing this to us on a platter. They're giving us exactly what we need. So then what would A sub 7 be, or the 7th term? It'd be 4 times 2 to the what power?
6.
To the 6th power. Remember, it's 7 minus 1. This is where you're going to want your calculator for sure, okay? You might be able to do this without, but if I kicked this up a notch, it would for sure be out. So some of you have the updated system and some of you don't. One thing I want to kind of caution you about is look what somebody might do. Okay, now if you actually don't want to make that a 6, if you want to make it 7 minus 1, see how that minus 1 is up here? If you don't have the updated system, your minus 1 might not be in your thing. So I just want to get this out of the way right now because some of you might be doing this. I want you to see the difference between these two. If you got 511, your minus 1 is not in your exponent. Honestly, I think it's easier just to go ahead and do minus 1 in our head. That's a thing we can do in our head and not get in trouble for. So that was 256. That was our answer. Okay, so if we look at B, okay, first of all, they're not giving us all the information like how they did. Remember, we need to find the first term, and we need to find R before we can even write the formula. Okay, so how could we find R? And I'm going to get my calculator ready. If you know the second term is 3.6 and the third term is 10.8, how could we use that information to find R?
Find the difference between them and subtract it from 3.6.
Okay, so remember, we're multiplying. 3.6 times R, that should equal 10.8, right? So I need to actually divide them. Now, if these numbers, if this was like second and fifth, that would be a little bit harder, and we'll get to that. So here the R is 3. How can we use that to then find the first term? How could we go backwards from the second term back to the first term? If the pattern is multiply by 3, how can we go backwards?
Divide.
We can divide. So we can go 3.6 divided by 3. And because there's already decimals here, I'm going to say it's fine to go ahead and have decimals. So then the first term would be 1.2, the R would be 3, and then this would be n minus 1. There's our formula. And then we're going to use that formula to find A sub 9, the 9th term. So 1.2 times 3, and then what number would be the power here? 9 minus 1 is 8. You can write that as 9 minus 1. Just be real careful when you're plugging that into your calculator. So I want you guys to go ahead and plug this in on your own and get an answer. There are some variations on what I'm doing, so if you're coming up with the answer a slightly different way, if you're getting the right answer, you're good. So here, if you're getting 7873.2, you're good. Now, decimals are fine here because I didn't have to round. It's still very accurate. But I do want to remind you that if I wanted that to be a fraction, all I would have to do is math frac. Oh, that's not going to like that one. I would have had to do that from the beginning with 1.2. But it's fine to have a decimal here because it started off with a decimal. I know before I was really warning you about using decimals. Okay, so C is kind of what I was warning you guys about before. Here's the 4th term, and we're going all the way to the 9th term. So how many times are you going to multiply by r to get from the 4th to the 9th? You're going to multiply by r how many times? 5 times. So I'm going to go 10r to the 5th because I'm multiplying by r 5 times. 10 times r times r times r times r times r. That should be this number. Okay, so how do we solve this expression or this equation? Well, first thing is we definitely want to divide by 10. I'll move this over here. Oh, no, over here. Well, it doesn't like that. That's okay. So 0, 0, 3, 2 divided by 10. And that's just going to move the decimal place, not 1. I'm off my game a little bit today, guys. Here we go. All right, and that's scientific notation. Now that's what r to the 5th equals. So how do I just find r? So the 5th root, how do we do the 5th root in our calculator? So if we go to math, if you go to 5, it'll do any root for you, okay? Yeah, we don't want it to do that. We want this to be the 5, and we want this right here to be that number. So if you go up there and you press enter, it should copy and paste it right in. Now, if you don't have the updated system, I don't know. It depends upon how old your operating system is. It may not like that. You may have to type in that number. Okay, the old way is you could have taken it to the 1/5 power, but you get 0.2. Okay, that's what r is, 0.2. You could have also done y1, y2, find the intersection. That works with pretty much any equation. All right, so all of that work to find r. Okay, what else do we need to write the nth term? We need a sub 1, right? So again, if this is the 4th term is 10, and I want the 1st term, I don't need to multiply by 0.2. I need to divide by 0.2. How many times? I mean, think about it. 1st term, 2nd term, 3rd term, and the 4th term is 10. If I go forward, I go times 0.2. If I go backwards, I got to divide by 0.2. So how many times do I need to divide by 0.2? 3 times. So you can do this individually, or you could use exponents. I'm going to kind of do this one individually. I'm going to go divide by 0.2. Again, there's other ways we could be doing this. Once, twice, 3 times. So 1250. Instead of memorizing all these steps, I'd rather you just kind of have a framework and then be able to answer questions off of that. So then the nth term, this is the easier part once you find these two. That's going to be 1250 times 0.2 to the n minus 1. And then from here you can find a sub 7. Now I'm going to go ahead and use this to find a sub 7, but we also could have either taken 10 and multiplied it by 0.2 3 times, or we could have taken 0.0032 and divided by 0.2 a couple of times. So you could come up with a sub 7 a few different ways, and that would be a good way to check your work. So when you type this in, you're going to get 0.08, or as a fraction, 2 over 25. Okay, so I know I spent a little bit of time on that. Series is actually easier. Okay, sequence is a little bit harder because of all the different types of things you can be asked. So, what's the difference between a series and a sequence? From last week. What do you do with a series? You can look down here. You're adding it up. So, a geometric series is the sum. That should not be an, that should just be a. Geometric series is the sum of a geometric sequence. And we have a summation formula. And it's really weird, but you don't have to memorize it. Okay, it's going to be the first term. A sub f is just stands for the first term. And then you got a fraction here. 1 minus r to the power of n, which n would be the total number of terms, and divided by 1 minus r. Okay, so we need the first term, we need r, and we need the number of terms. Unlike the arithmetic series, we don't need the last term. So that's kind of nice, although they're giving it to us here. Okay, so let's go ahead and start with what we know. 1.4 is the first term. And we know we're going to have a 1 minus and a 1 minus. I like to just start with what we know and then figure out what we don't know. Okay, r. They don't flat out tell us r, but can you figure it out? How do you get from 1.4 to 2.8 to 5.6 and so on? What are you multiplying by? 2. If you're not sure, what you need to do is do 2.8 divided by 1.4, 5.6 divided by 2.8 until and they should be the same number. And that's how you know. All right, how many terms are there? 9. They could have made us figure out how many terms there were, but they didn't, which is kind of nice. Okay, where most people mess up here is with the typing in the calculator. Okay, so 1.4. Okay, parenthesis. Then we're going to go 1 minus 2 to the power of 9. Hit the right arrow to close the parenthesis. And then do divided by, sorry, let me hit that divided by a little bit harder. Divided by parenthesis 1 minus 2.
It's like 1.4 and just hit times 2 until you get to 9.
And then just add them all up? Sure, you could do that. What if that said 92 terms? But yeah, there's going to be other ways to do these. These formulas really just are more a succinct way of doing it. But yeah, you could find all 9 terms and just add them up. For sure you could. Okay, so there's our answer. Okay, so for part B, again, we're given the first term. They don't say how many terms, but they kind of let us in on a secret here with the 6. They tell us that there are 6 terms with the S sub 6. We still need to figure out R. So if it's not obvious to you what R should be, you need to use your calculator. You need to do negative 18 divided by negative 12. And then you need to check it again. Negative 27 divided by negative 18. It should be the same number, 1.5. So your R here is 1.5, or you could use the fraction 3/2. Either way, one would work. So your sum is going to be your first term, 1 minus, now if you use the decimal, 1.5, take it to the 6th power on the top, and on the bottom, you don't have an exponent. So that's how you type it in. Negative 249.375. always want your answer to be as accurate as you can. That's why we're kind of emphasizing fractions before. This, though, is 100% accurate. I didn't even have to round, so it's still good. You can always do math fraction to get your answer as a fraction if you needed to. Okay, remember this Greek letter? What is that Greek letter right there?
Sigma.
Sigma, and it means to add it up. And we're going to start with 0. Notice, by the way, this is a little different than the one we had before. So to find our first term, we need to actually plug 0 in to this expression. Anybody able to do that in your head? What's 1/2 to the 0? 1 times 6 is 6. You have a calculator, though. You don't have to do that in your head. Okay, we also need R. It's always going to be the number in parentheses, so 1/2. And we need N. We learned last week that this is a little tricky. I can tell you there's not 10 terms. If you start with 0 and end with 10, how many terms is that? Count them on your fingers if you need to.
11.
11, because you're counting the 0 and the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You always add 1, so subtract these and add 1. That's really kind of the shortcut. So if I want to do the sum, I would take the first term of this series, which is 6. You always get that by plugging the number in here, in for I. And then 1 minus, now this is going to prove to be interesting right here, this fraction. You could change it to 0.5, but I want to show you how you get around this in your calculator. So we go 6 parentheses, 1 minus. I'm going to put 1/2 in its own parentheses like that. Like nested parentheses. So that when I take that to the 11th power, I know I'm taking all of 1/2. You can also include them in the denominator, although it's not necessary.
What is the I like on the outside of the bracket mean?
It's the same as n, except we don't use n because n technically means the total number of terms, but it's just using a different letter. It could be I, sometimes it's j, sometimes it's k.
So if it's like -1, does that mean you subtract? That's what you're looking at.
It doesn't really mean, sometimes it's going to be an I, sometimes it's going to be an I minus 1. You're going to approach the problem the same way. You're going to plug in the number at the bottom of the sigma to find your first term. The number in parentheses is R, and then your number of terms is subtract plus 1. All right, now, this right here is an answer that's accurate to 3 decimal places, but it's just that. It's not actually totally accurate, okay? It's not that this is bad, and now I'm spinning, but you can hit a math fraction here and get a fraction. I'm not saying that that's like something you have to do, but there you go. Okay, I want you to do the, where it says, okay. And there we go. There's the fraction, okay? That's more accurate than rounding the decimal. Okay, so if we look at this next one, is the first term still 6? If we start with 1 instead of 0. Well, no. It's 1/6 times 1/2 to the power of 1, which is going to turn out to be 3. Rn is still going to be a half. N, what is n? We start with 1 and end with 10. So when we started with 0 and ended with 10, we had 11. What if we start with 1 and end with 10? Like, just count it on your fingers if you need to. It is going to be 10. The shortcut is to subtract these two numbers and add 1, considering you're including both the starting and the stopping, but always just add on your fingers if you needed to. So is this going to give me a different answer? Well, certainly it is. You don't have to retype the whole thing in, though. You could just go up here and edit what you wanted to edit. So go over here, change this 11 to a 10, and go to the front and change that 6 to a 3.
Would you count off if we didn't do math back?
No, I don't think so. It's just not as accurate when you have to round. Okay, so last one. We have to find this term, which is the third term. And now all we have is a 3 to the power of 3. So 27 is the first term. What's r? Look at what I did in the previous problem. R is always the number in parentheses. It doesn't matter how simple or complicated it is, R is the number in parentheses. And the number of terms is to subtract these two and to add 1. So 12 minus 3 is 9, plus 1 is 10, or you can count on your fingers. So my first term, 1 minus r. So go ahead and type this in and check with the answer up here when you get it.